Hi guys, Mrs. Vara here. I'm going to do a couple examples, not everyone, but a couple from lesson 12.5. So this is solving. We've done some solving already, but this is solving an addition and subtraction problem. Okay, so take a look at the steps we have here in your notes, and we're going to kind of follow those steps, and I'll show you how it works. I'm not going to do A here. It's a little bit of an easier one. I'm going to do B, because it's a little bit trickier. Same process though. You're going to find the least common denominator of all fractions in the numerator and denominator. So I'm just going to turn this one into a fraction. And I'm going to say, all right, least common denominator of all three of these would be, least common denominator would be x times x plus 5, which in this case is also the greatest common denominator. Okay, now, then it says multiply numerator and denominator by least common denominator. So we're going to do something a little different with these. We're not going to find a least common denominator in order to actually do the subtraction. We're going to use the least common denominator to, I'm going to say, clear out the denominator, like we did in 12.4. My camera keeps doing something weird. Hopefully it'll stop. So our goal is to get rid of these fractions, and we're going to do that by multiplying each term. We have to make sure we do each term by the least common denominator. So there's different ways to write this. I'm going to do it like this. I'm going to say I'm multiplying each term by the least common denominator. So I'm going to write the least common denominator as a fraction just because we're multiplying two fractions. And then I'm going to write my problem here. I'm just showing that I'm multiplying the least common denominator. Here, by both of these terms, I recommend you do the arrows to remind you to distribute. I have to multiply by this term, and this term. And then I'm going to do equal. I'm going to put my 3 over x. And then I'm again going to copy my least common denominator that I'm multiplying by. So I'm multiplying all three parts of my equation by this least common denominator. So if you look at this, you can think, all right, when I multiply fractions, I multiply the numerators and I multiply the denominators. So if I picture multiplying this numerator, I'm just going to have x times x minus 5 all over 1. So that's these two. Now when I multiply this by the second fraction, I'm going to have the minus in there. In the numerator, I'm going to have x times x minus 5 times 8. So that's going to look like this. 8x times x minus 5. Just multiplying all these terms, writing them together, over 1 times x minus 5. Okay? And then over here, I'm multiplying numerators. So 3 times x minus 5 would be 3x times x minus 5, all over x. Now when you get better at these, you probably won't write this step because you can look ahead and see what I'm about to do. X times x minus 5 over 1 is just x times x minus 5. If you notice this fraction right here, I have x minus 5 divided by x minus 5, so those 1 out, and I'm left with 8x. Equals, if you notice here, I have x divided by x on the top, x on the bottom. Those 1 out, and I'm left with 3 times x minus 5. So this is why I say we use the least common denominator to clear out the denominator. Because you notice, after I multiply each term by this least common denominator, my denominators are gone, and I'm just left with an Algebra 1 problem, if you want to think about it that way. So now I'm going to distribute here and combine like terms. I'm going to get x squared minus 5x minus 8x equals 3x minus 15. You should be able to pause me right now and do the rest of this yourself. This is going to be x squared minus 13x minus 3x plus 15 equals 0. So what I'm doing is I notice this is a quadratic. So I'm gathering all my terms on one side of the equal sign, 0 on the other. Combine like terms, x squared minus 16x plus 15 equals 0. I'm moving fast, but it is a video. If you lost me, pause it, go back, see if you can catch up. This is a quadratic. 3 ways to solve a quadratic: graphing, quadratic formula, or factoring. I'm thinking this is factorable because I'm noticing 15 times 1 is 15. 15 plus 1 is 16. This is plus. That tells me both of the signs in my parentheses will be the same. This tells me they'll both be minus. To get an x squared, I have to do x times x. To get a 15, I have to do 1 times 15. Alright, so there's my factored form. Remember, this is a solve problem. I'm solving. Zero product property says two things equal to 0. One or both of them must be 0. So x equals 1 or x equals 15. Now you'll notice on the steps up here, here's the steps again, simplify, check for extraneous solutions. So we need to do that in these. I am likely not going to do it in this video, but you need to know every time you do one of these solve problems, you need to take this x equals 1, go back to your original equation, replace the x with a 1, and make sure that what you get when you simplify on the left side of the equal sign equals what you get on the right side of the equal sign. And then you need to do the same thing with the 15. Plug 15 in here, simplify the left side of the equal side, simplify the right, and ensure you have the same number on the right and the left. You can do the simplifying in your calculator. I can tell you that both of these check out. So these are both solutions. There are no extraneous solutions in this one. And then we want to do our excluded terms. So we want to go back to the original. We didn't really factor the denominator, and I want to think what would make the denominator here and the denominator here 0. Well, that would be when x equals 5, so we're going to say x cannot equal 5, and we're going to say x cannot equal 0. Okay, those are our solutions. So the other problem I'm going to do from 12.5, these are your turns. Try those, notes are posted, you can check your answer. There might even be some videos from the book of those problems. But I am going to quickly go through, let me see, yeah, example 2. This is one where you have extraneous solutions. It even tells you here, you have extraneous solutions. Now, this is why you need to check, because you never know when you're going to get one of these problems with extraneous solutions. So first thing I want to do here, I need to find least common denominator, but I notice this can be factored. So I'm going to factor that denominator first. So 8x squared, this is a binomial, perfect squares, so that factors into x plus 3, x minus 3, minus 4x over x plus 3. So now least common denominator here. Here's my three denominators. X minus 3 times x plus 3, and x plus 3. So my least common denominator, I'm going to need an x minus 3, and I'm going to need an x plus 3. Okay, so that's my least common denominator. Now I want to multiply all three parts of this by my least common denominator. So I'm going to work this way, and I'm just going to put my x plus 3, x minus 3 times this, so that's this, equals, I'm going to write my equation here. This is x plus 3, x minus 3, minus 4x, x plus 3, and then I want to show I'm going to multiply this whole thing times x plus 3, x minus 3. Okay? I'm not going to do the in-between step this time. I'll show you what I mean here. I'm going to clear out my denominator while I multiply here. So I'm going to keep my equal. I'm working down with my equal sign. I can put a 1 under there. So my numerators are x plus 3, x minus 3 times 6. My denominator is x minus 3. So x minus 3 on the bottom, x minus 3 on the top. There we go. I cleared out my denominator. On the top, I have 6 times x plus 3. Okay, now multiply this by both of these terms. So when I multiply by this term, you'll notice I have x plus 3 times x minus 3 on the bottom and x plus 3 times x minus 3 on the top. So those are going to clear out completely. And what I'm going to be left with in my numerator is just 8x squared. Minus, from this minus. Here, when I multiply this fraction by this fraction, this is my numerator, all of these. My denominator is x plus 3, so the x plus 3 clears out, and I'm left with 4x times x minus 3. Okay, now, algebra 1 equation, we cleared out our denominators. So I'm going to have 6x plus 18 equals 8x squared minus, watch your negatives here, negative 4x times x squared would be minus 4x squared. Negative 4x times negative 3 would be plus 12x. Quadratic, everything on one side, 0 on the other, combine like terms. Do it on your own. I'm skipping steps, but you should get that. I think I want to solve this by factoring, but I'm noticing I have a greatest common factor of 2. So I can factor out a 2, or because this is an equation with a 0 on this side, I can think, well, I'm just going to divide everything by 2. Remember, when you have an equation, you can multiply or divide by whatever you want, as long as you do it to both sides. And so then this is going to make this nicer, easier to factor. Factor that, you should get this. Okay, solving a quadratic here. So x equals 3 over 2, or x equals negative 3. Now I already said this one's going to have an extraneous solution. So what I need to do is plug both of these in and check. See which one is correct and which one is an incorrect solution. Before I do that, I want to go back up here to our original problem after I factored everything, but before I did all this math on it. So this is my original problem in its factored form. So if I look at all these denominators and I identify my excluded terms, what x cannot equal, because it would create a 0 in the denominator, I would say excluded terms are positive 3 and negative 3. So if I go down here and say x cannot equal 3 and x cannot equal negative 3, and then I look, well, I cannot have the solution x equals negative 3 because I just said that's an excluded term. So this is my extraneous solution. The only correct solution is 3 over 2. And I knew that even before I plugged it in, because if x equals negative 3, it would make my denominator right here 0. So these are excluded terms, and this is my answer. Now real quick, say you tried to check this answer, x equals negative 3. So you'd go up to your original problem, and you'd put a negative 3 in here, and you would get negative 3 minus 3 on the bottom, so you'd get negative 6. When you put a negative 3 in here, negative 3 squared is negative 3 times negative 3. That's positive 9 minus 9. You'd get a 0 here. As soon as you get a 0 in the denominator, you should realize something's wrong. If you put a negative 3 in here, negative 3 plus 3 is 0. You'd get a 0 in the denominator. So it wouldn't check out when you went to check it, because you'd have two fractions that were impossible because they were divided by 0. So that's what it looks like when you have an extraneous solution. Okay, that's it.